Welcome to the Innovators, the podcast where we talk to the people building the future. In each episode, we sit down with technologists, founders, researchers, and engineers who are doing real, impactful work. They're applying technologies in ways that change how we live, work, and think. Whether it's breakthroughs in AI, climate tech, health systems, or digital infrastructure, this show is about the people turning ambitious ideas into working systems. No hype, just thoughtful conversations with the folks making it happen. Amazing people doing amazing things. One of these amazing people is Evan Brokowski. He's the CEO and founder of Kimaru AI. You're calling us from just outside of Tokyo, which is wild to me that you would put up with this. It's like 10 o'clock there, right?
Thanks so much. Yeah, exactly. It's 10 p.m. right now.
There you go. All right. So that's so Kimaru is a pretty big project. You guys just graduated from Alchemist. Why don't you tell me what you're up to?
Sure. So essentially what we're building is decision intelligence for the global supply chain. Decision intelligence is an emerging field. It basically allows for the commercial actualization of AI without error, without a lot of the hallucination problems. And in many ways, it's like the next generation of AI for commercial application. And as you can kind of imply from the name, it's a continuation on from the previous analytics and business intelligence discipline, new software category. Gartner will be launching their Magic Quadrant this year for the first time. So essentially what we do is instead of systems of record that give a backwards-looking view, we use prescriptive AI to give a forward-looking view and make recommendations on things like inventory management, when to replenish, when to repurchase from suppliers, how to manage pricing optimization, route optimization, things like this. Essentially, we allow people to make real-time decisions across the entire supply chain to deal with all the ongoing chaos that people experience these days. And as Accenture has identified, there's a $1.6 trillion loss across the global supply chain and trillions of dollars that get tied up in safety stock just to deal with potential spikes in demand or delays in supply. And that money obviously could be much better invested across the business.
So who does this job right now? Is there like one person who sits there and says, okay, well, we got to put this box into this ship to get it there in time, something like that?
We actually help people who have about 100 different titles across supply chain because what we're building is what we call a large market model. We're connecting all the stakeholders in supply chain, everybody from manufacturers to their suppliers, through retailers, big brands. The titles of our users are things like procurement manager or inventory manager. We work with, it might be VP of supply chain. It might be a local distribution center manager or even a local retail manager at the supermarket level or convenience store level. Quite a wide range of different profiles and verticals.
So, but we're not talking about the guy running the crane. We're talking about somebody who's been using a spreadsheet for now and doesn't have any forward visibility.
Precisely. We have talked to hundreds and hundreds of people across supply chain. 100% of them are doing this job in spreadsheets right now. It's really the only connective tissue that there is across these systems of record, ERP, point of sale systems, CRM, and so on. And so what we do is we create a decision operating system that sits on top of these systems. It doesn't replace them, but it augments them. And it augments them both with this forward-looking AI and a human-in-the-loop process, what we call decision augmentation, not automation. So we're not taking anybody's jobs, we're augmenting their jobs, and essentially creates a continuous learning system with reinforcement learning through human feedback and a human in the loop circuit breakers that all critical decisions are checked by the human user.
Yeah, that was one of my questions. How do you make sure that this thing doesn't, say it's going to need 5 million widgets when it only needed 1 million that year or that quarter? What are the controls in place, and what's the limit to its quote unquote prediction ability?
Well, what we do is build a decision digital twin for each user and their stakeholders. This is a cross-organizational decision-making layer. And those decision digital twins are built off of historic KPIs. So the KPIs that are being tracked in those spreadsheets or ERP systems of record and so on. Once we've built that decision digital twin, it defines the parameters, the outcomes that we're tracking and the actions that the users can take. And then they set the, let's say, circuit breaker level depending on their tolerance for automation. The goal, of course, is to automate some of the processes. It's a multi-agentic system with dozens, eventually hundreds of vertical agents that we're building out. And those agents do the heavy lifting, the manual jobs of data connection, normalization, ratification, and so on. We want those processes automated because they're very low risk. But then when it comes to a critical decision like actually reordering more inventory, we don't want the agents going off and just ordering 5,000 widgets or whatever it might be. And so the human user reviews all of these recommendations that are surfaced by the AI, adjusts them as they see fit based on their experience and critical thinking and sometimes creative problem solving. And that creates a feedback loop. So the agents are learning from the human preferences over time. And it's an unlimited memory window, continuous learning system. So it always gets more accurate over time. But the final action is sent down into what we call the action layer with the existing systems in place, the existing checks and barriers in place. So once a decision has been modeled out and then sent to the action layer, it goes back into the ERP or RPA, whatever system the business is using right now to actually order that inventory, create a purchase order, and so on.
How does this work how does this work for smaller carriers? So let's say, like, what it sounds like is you're talking about like a huge, like, I don't know, a shipping carrier, right? Somebody who's doing massive quantities of goods. How do you expand this out into trucking? How do you expand this out into the guy with a truck, right? Who wants to know which load to pick up first?
Well, that's more on the logistics side. Our primary users are more retailers, manufacturers, and their suppliers. So a practical example would be, we're working on some POCs right now for electronics manufacturers in regions like Taiwan. They need copper wire, they need chips, they need components that go into high-end electronics, and then they service these products for their downstream retailers, which might be, well, in this case, high-end audio-video brands. And so they have to move the items around. They have to manage their fleet. They have to do route optimization. They have to manage potential spikes in demand, the correct amount of safety stock inventory, and also the pricing of those items. And right now, a lot of these manufacturers are heavily impacted by tariffs. And so they're changing their supply chains from traditional routes like China into Vietnam, developing new relationships. This requires the management of fallback suppliers and alternate shipping routes and so on. So our users that we can best service are those who have a fair amount of complexity in their supply chain, but that can be very small companies that have a lot of different components that go into their finished goods, or maybe service quite a few different retailers. Essentially, what those small retailers have been doing is managing these in pivot tables. That's our primary competitor. That's who we replace for the most part. And so we bring in a much more cost-effective solution. We do all the heavy lifting, modeling all of that out, and then essentially running on that decision digital twin. What we're creating is every potential permutation of the decision they could make. So we're running these simulations and coming up with the single best answer, that single best recommendation that makes the most sense. Human user checks it, approves it, and if it's good, that process can take 30 seconds instead of the weeks that it used to take. So it's considerably more time efficient. It's allowing these smaller retailers to be much more efficient with their human resources, and of course it scales up all the way to the largest retailers and manufacturers that you can imagine.
And the manufacturers don't have this yet?
Well, most of them have some components of this. But what we're doing is bringing a patented architecture which is scalable. So these are decision digital twins speaking to each other, and then again, a large market model. What we do is run pilots with forward deployed engineers that build out the data connectors and the various vertical agents that are required for each user. And we usually sync up with R&D teams that are building some components of this already. So they may have the data improvement, let's say, project underway. They might be using a data lake, maybe Snowflake or Databricks. That helps because essentially the underlying layer of our platform is a data lake. And if we can plug into Snowflake or Databricks, that helps quite a lot. Sometimes they've gotten as far as building vertical agents, but they maybe haven't got as far as our patented architecture, which combines these underlying data sources with the decision digital twin that can speak to other decision digital twins in a architecture that is very compliance and governance friendly. We use federated learning so that the raw data stays on site, on premise, and we share the learnings across the overall network. And then everything is tracked in the blockchain with smart contracts. So very, again, compliance and governance friendly. Yeah, so a lot of the teams we work with for large brands have some components of this built out, but almost nobody we've spoken to has the entire system built out yet. So we help them actualize the underlying work that they've been doing and bring that to fruition.
And you guys are raising right now, or have you already raised?
We are raising our seed round. We're just speaking with a lead investor, and in the next week or two, we'll be looking for follow-on investors for that round.
And how's it going so far? It looks like people are interested.
Great. Yeah, we are quite honored and happy to be in the 25th percentile for our cohort. Interest has been extremely high. We had a huge number of inbound calls from investors, so much that it's taken a couple of weeks to go through that whole process. But we exceeded our target for the pre-seed round. We've closed 2 investments since demo day, so we're closing out that pre-seed round and opening seed.
Very cool. So we can send folks over to kimaru.ai to check it out. I think it might be a little bit specific for a B2C, but I think B2B would get a kick out of this.
It is very much B2B.
Yeah, it's not fun AI, but if you can make it easier to send a transistor from Taiwan to the States, that sounds like a lot of fun.
We purposefully set out to solve a somewhat boring problem. A lot of people really think about where the clothes they wear or food they eat comes from, but supply chain is a huge problem. It's a multi-trillion-dollar global problem. So yeah, in that regard, it is a little bit boring. And a lot of what we're using is actually the workhorse AI that's been in production for going on 10 years now. These recommendation and prescriptive recommendation algorithms, they're the things that power the movies that get recommended to us or the products that we see when we go on Amazon. I've spent the past 10 years of my career selling those type of systems in Japan, and prior to that, like advertising and A/B testing recommendation systems. So that's what my focus has been.
Yeah, that's actually a really interesting point. I mean, you're talking about AI that's been this, the way you describe it, it's almost like I don't know, it's like a chess computer, right? Running those moves out for X number of million times is something that's been done for decades now. But I suppose it's much faster and a lot easier to use at this point.
Precisely. And it gets more interesting all the time. We've been working with neural networks using different simulations like Monte Carlo and random forests. Now we're getting into some really neat stuff, which is based off our CTO's PhD research. Things like, basically, his PhD was in decision systems and universal modeling systems for recommendations. So we're using some of that to build chaos engines and building off of like fractal simulation, and had some really interesting conversations with potential quantum partners. The ability to run the simulations is now really only limited by the compute power, and that's growing all the time. So it's a really exciting field. And I like to make this distinction because, again, a lot of this is like really commercially viable workhorse AI. We've seen, some building backlash recently against the whole category of AI as, I think it was 3 weeks ago now, MIT put out a report that about 95% of generative AI commercial pilots are simply not working out. And that's because, in our viewpoint, they're missing the underlying decision digital twin, that causal layer that gives something for the AI to run on. And generative AI by itself is probabilistic by design. It's not deterministic. What's required is this decision intelligence layer that allows it to run in a deterministic fashion, reduces the stochasticism, and it gets rid of that error rate and hallucination. So it's really a commercially viable AI. That's how we like to think of it.
Right, well, Evan, thank you for joining us. This has been great.
Yeah, thanks very much. It's been great chatting with you.
All right. This has been The Innovators. I'm John Biggs. We will see you next episode.